Okay, so in this lesson we're going to talk about the identity and inverse properties. Let's start with the identity properties first. Let's consider this statement. If I have 3 plus and then some box here equal, and I want 3 back. So if I start with 3 and I want to end up with 3, then what number could I add to 3 and get 3 back? And so this is pretty simple. I mean, obviously you said 0, so I'm going to put 0 here. Now, if I look at let's say this number here, -4 plus what number equals -4, then again you would say 0. So if you look at this, this number I start with and I want to end with that same number, notice what was in this box. 0 is in this box. Okay, so what that means is that the number 0 is called, the identity for addition. All right, so the number 0 is called the identity for addition. So basically the reason is because when you add 0 to any real number, you get that same number back. Okay? Now let's look at this. Suppose I had 6 times some number equal 6, or 8 times some number equals 8. -2 times some number equals -2. So if you look at what you have here, these numbers here, you want to get the identical number here. And so same thing here, when you start out with 3, -4, you wanted to add some number to it, so that way you got the identical number back. And so hence the word identity. Think of identical identity. So in this case, though, we're dealing with multiplication. So what number do you think should go in these boxes? So that way, when whatever this number is, you multiply by these real numbers, you get that real number back. So if you said 1, that is correct. And so regarding that same idea here, we're going to talk about 1. So the number 1 is called the identity for multiplication. So the number 1 is called the identity for multiplication. And so whenever you have a real number and you multiply by 1, you get that real number back. All right? Okay, so basically the identity of real numbers is not changed in either of these cases. So 3 plus 0, you get 3 back. It's not changed. It's still 3. -4 plus 0 is -4. It's still, it hadn't been changed. 6 times 1 is 6. 6 hasn't been changed. 8 times 1 is 8. 8 hasn't been changed. So hence the idea of identity, identical. All right, so in terms of a definition, let's just look at this. So the identities for addition and multiplication. All right, so let's talk about this. So from all this discussion, we know that 0 is the identity element for addition. Right? So basically that means that if I have a real number and I add 0 to it, I get that real number back. And again, I could have said, instead of saying a plus 0, I could have said 0 plus a. It does not matter. Remember, addition is commutative. And then 1 is the identity element for multiplication. So basically, a times 1 is going to give me a back, and I could have said 1 times a will give me a back. So remember, multiplication is commutative as well. A times 1, same as 1 times a. Okay? All right, so let's look at the idea of additive inverse. All right, so we talked about identities. Now let's talk about identities. Now let's talk about inverses. So let's look at this idea. So now we're going to talk about inverses. Okay, so there's something called an additive inverse. Additive inverse. And another word that sometimes we use for additive inverse is called opposites. Opposites. All right, so additive inverse or opposites. Okay, that'll be the first one we're going to look at in terms of inverses. Additive inverse or opposites. Okay, so keep this in mind. So two numbers are called additive inverses. Additive inverses or opposites if their sum is 0. Okay, so two numbers are called additive inverses or opposites if their sum is 0. Now, let's think about the idea of opposites. It's easier to think of opposites because you dealt with opposites before. So, for example, the opposite of 6, and think of the number line. So this is 0 and this is 6. The opposite of 6 from 0, so if this is 6 units from 0 and you go 6 units to the left, the opposite of 6 is -6. So the opposite of 6 is -6. The opposite of -8 is 8. Okay? So in terms of the number line, they're on opposite sides of 0. Opposite sides of 0. Now, the interesting thing is this. When I add these numbers up, when I add 6 and -6, which are opposites, or additive inverses. Remember, additive inverses and opposites are the same thing. Additive inverses. Their sum is 0. So 6 plus a -6 equals 0. 8 plus a -8 equals 0. -5 plus a +5 equals 0. Okay? So two numbers are called additive inverses or opposites if their sum is 0. Now, so notice I said the opposite of -8 is 8. I could have said this as well. So note, it could be like this. The additive inverse of 10 is -10. All right, so instead of using the word opposites, we could use the word additive inverse. All right? Okay, now let's look at number 2. All right, so again, we're still dealing with word inverses. The first one is called the additive inverse or opposites. The second one in terms of inverses is called, multiplicative inverses. Multiplicative. Or reciprocals. Multiplicative inverses are reciprocals. Now you talked about reciprocals before. Let's look at the idea of reciprocals. The reciprocal of 2/3 is, and remember, just take the reciprocal of that fraction, is 3/2. The reciprocal of 2/3 is 3/2. And don't say negative 3/2. All right. First of all, 2/3 and negative 3/2, they have no relationship in terms of inverses. And don't say 2/3 negative 2/3, because those are actually opposites. Those are additive inverses. We're talking about multiplicative inverses, which another word for it is reciprocal. So remember, all you do is just take the reciprocal of the fraction. The numerator becomes the denominator becomes the numerator. The reciprocal of negative 4/5 is 5 over negative 4, or you could have said negative 5/4. It does not matter. Keep that in mind. You could say 5 over negative 4 or negative 5/4. It does not matter. Okay? So notice the signs are the same in either case. Positive, positive, negative, negative. It's just that I took the reciprocal. The numerator becomes the denominator becomes the numerator. And again, instead of using the word reciprocal, I could have said the multiplicative inverse. So I could say this: the multiplicative inverse of negative 3 is, all right, now notice this is an integer. Those were rational numbers, fractions in particular, but this is an integer. Keep in mind that I can write this as negative 3 over 1. Okay? So using the idea of negative 3 over 1, I can rewrite this by taking the reciprocal. So the reciprocal of negative 3 is negative 1/3. The multiplicative inverse, or opposite, does not matter. Could use the word, I'm sorry, I didn't mean opposite, I mean reciprocal, or reciprocal of 5 is 1/5. Okay, so the multiplicative inverse, or the reciprocal of 5, is 1/5. The multiplicative inverse of 1/8 is 8. You get 8 over 1, which is just 8. Okay? All right, now there's something interesting about reciprocals. Now remember, we're talking about multiplicative, so the operation multiplication. So if you multiply, let's say 2/3 times 3/2. And remember, those two numbers here are reciprocals. They're multiplicative inverses. But if I multiply, notice what happens. So if you multiply, you end up with 2 times 3 is 6, 3 times 2 is 6, which is 1. So if I look at 5 times 1/5, so if you multiply, let's say 5 times 1/5, and remember 5 is the same thing as 5 over 1. Notice that those are reciprocals, those are multiplicative inverses. But if you multiply them, 5 times 1 is 5, 1 times 5 is 5, you also get 1. So whenever you are multiplying reciprocals, your product is going to be 1. Okay, so your product will be 1. So the thing I want you to get from this is this. 2 non-zero numbers are called reciprocals or additive are multiplicative inverses if their product is 1. If their product is 1. Okay? All right, now, let's see. Okay, now, so we talked about in terms of inverses. So far, we've done this so far. So in terms of inverses, we've talked about the additive inverse, which is the same thing as opposite. And we've also talked about the multiplicative inverse, which is the same thing as reciprocal. Okay? All right. So using the idea of letters now, let's look at this. So I'm going to rewrite all this using letters. All right, so let's talk about the definition. So additive or multiplicative inverses. So let's kind of summarize what we just did. Okay, so the numbers A and negative A are additive inverses or opposites of each other because their sum is 0. Okay, because their sum is 0. So basically you're saying A plus a negative A is going to equal 0. All right, now let's talk about this. The numbers, B and 1 over B. And remember, you see how this variable is in the denominator and you can never divide by 0. Remember, 0 can never be in your denominator. So I'm going to put this right here where B cannot equal 0. All right. So as long as these are non-zeros, remember, non-zero. So non-zero means any number other than 0. So as long as in terms of multiplicative, as long as this number is not 0, we're good. So this can be any number but 0, because when I take the reciprocal, I cannot divide by 0. All right, so the numbers B and 1 over B, as long as B does not equal 0, are reciprocals or multiplicative inverses of each other. Because their product is 1. Because their product is 1. So in other words, B times 1 over B has to equal 1. Okay? All right, so now let's look at some examples. Okay. All right. So you're going to be given some expressions, and let's say one of the expressions is, let's say expression here. Oops, sorry, can't see it. So let's say expression here is 3. And I want you to determine the additive inverse. I want you to determine the additive inverse. Well, remember the additive inverse, another word for additive inverse is the word opposite. So if my expression is 3, then its additive inverse is a negative 3. All right, let's go about multiplicative inverse. All right, now remember, The reason it's called an additive inverse is because when you add these, you get 0. 3 and negative 3 is 0. Multiplicative inverse, another word for that is reciprocal. Okay, reciprocal. So the reciprocal of 3 is 1/3. Because when you multiply 3 and 1/3 together, you get 1. Remember, the identity element for addition is 0. 3 and negative 3 is 0. The multiplicative identity, or the identity element for multiplication, is 1. 3 times 1/3 is 1. Okay? Right, now what if you had this? What if you had, let's say, negative 7/8? So if my expression is negative 7/8, then the additive inverse, remember another word for additive inverse is opposite. The opposite of negative 7/8 is a positive 7/8. So when I add them up, I get 0. So remember, the identity element for addition is 0. So when you add them up, you get 0. For the multiplicative inverse, remember the multiplicative inverse, another word for it is reciprocal. So when I take the reciprocal of negative 7/8, I get a negative 8/7. So when I multiply negative 7/8 and negative 8/7, I get 1. Let's say I had x. The additive inverse of x, the opposite of x, is a negative x. When I add x and negative x, I get 0. X minus x is 0. The multiplicative inverse is take the reciprocal of x. So the reciprocal of x is 1/x. Okay, let's look at 2x. All right, the additive inverse of 2x, remember, is you take the opposite, so the opposite of a positive 2x is a negative 2x. The reciprocal, the multiplicative inverse of 2x, the reciprocal of 2x is 1/2x. Okay? All right, so that's the idea of additive inverse and multiplicative inverse. So additive inverse, another word, is opposite. So notice all of these right here are opposites of these. Multiplicative inverse, another word for multiplicative inverse, is reciprocal. All of these are their reciprocals. Okay? All right, now, the other thing you have to be able to do is name the properties illustrated by each statement. Actually, we're going to do that in another lesson. So let's stop this lesson. Let's stop this because all this was about was discussing the inverses, discussing the identity and inverse properties. Well, let's go ahead and do it now because some of these involve this, and it won't take that long. So let's just name the properties. So name the properties. Name the properties illustrated by each true statement, each statement. All right, now do not abbreviate. Do not abbreviate. Okay, so number one, suppose we had this. Negative 5 times x equals x times a negative 5. All right, so negative 5 times x equals x times a negative 5. So what property says that negative 5 times x is the same as x times negative 5? So look at it closely. Look at this side and look at this side. So remember, this is multiplication. Negative 5 is listed first here, x is listed second, but here x is first and negative 5 is second. So remember, that's the commutative property of multiplication. So the commutative property of multiplication. So that's what we're talking about. So we're taking all these properties we've learned in these several lessons and putting them together. All right, now what about this one? Suppose I had 6 times 2x minus 5, and I'm telling you that's going to equal 6 times 2x minus 6 times 5. So remember what that's called? So look at this. Look at the right-hand side. So 6 times 2x, and then minus 6 times 5. So if you said the distributive property, that's correct, but go ahead and write it like this. The distributive property of multiplication, again, don't abbreviate, over addition. Okay? All right, next one. Suppose we had this. 5y plus 2 plus 2x is equal to 5y plus 2 plus 2x, just like this. Okay, so look at this side, look at this side. So remember, notice that the terms are in the same order. You see it? 5y, 2, 2x. But I'm grouping different things. So you remember what that's called? So here I'm grouping the first two, here I'm grouping the last two. So remember, that's called, you're going to use the idea of association. So that's called the associative property of, and the operation here is addition. So the associative property of addition. Okay, associative property of addition. 4, suppose you had negative 6 plus 0 equal negative 6. We just talked about that. What do you think that's called? So I started with negative 6, and I ended up with negative 6. All right, so that's called the identity property of addition. The identity property of addition. All right, what about number 5? Suppose number 5, I had this. Number 5. 8 times, let me use a different one. 11 times 1 over 11 equal 1. 11 times 1 over 11 equals 1. All right, now, so remember, let's kind of talk about this. So remember we talked about 3 and 1/3. So if I multiplied 3 times 1/3, I ended up with 1. Remember that? So that's called the multiplicative inverse. Multiplicative inverse. A multiplicative inverse property. Okay. All right. Now, what about this? Let's look at this idea. Let's see. All right. Suppose we had 6. Suppose we had negative 8 plus 8 equals 0. What do you think that's called? Negative 8 plus 8 equals 0. So again, I want you to look at this chart. When we did this, we said 3 plus negative 3. What did that equal? That equals 0. So I was using the additive inverse, the additive inverse property. So the additive inverse. So remember, the additive inverse says when I add two numbers that are opposites, I get 0. And that's what you're doing here. I'm adding two numbers that are opposites, I'm getting 0. So that's called the additive inverse property. Okay. Let's look at this idea. 8. This is 7 rather. 7. Okay, suppose I had gotta be a little bit careful with this one. Alright, so let's suppose we had this. 5 plus 0, now be careful with this one. 5 plus 0 plus 6 equals, let's make this x right here, I'm sorry, x. So x plus 0 plus 6 equals x plus 6. Alright, so think about that for a moment. So you have in parentheses x plus 0 plus 6, and then all of a sudden I just have x plus 6. Alright, now remember, x plus 0, what I'm saying here is that x plus 0 is equal to x. Okay? So x plus 0 is equal to x. So remember right here, in number 4 that we did, when I had negative 6 plus 0 equal negative 6, what was that property called? Well, it was called the identity property of addition. So here, I'm using the fact that x plus 0 is equal to itself. So, and everything else stay the same. So I'm using, what you can say is this, I'm using the identity property of addition. I'm using the identity property of addition. Even though it doesn't look like number 4, I am using it though. X plus 0 is equal to x. Alright, so let's, alright, what about this one? Let's do one more, number 8. Alright, so 7 and 8 are a little bit more difficult. So let's look at 8. Suppose I had 8 times x times 7 is equal to, let's say, x times, and let's say 8 times 7. Right, so it's a little bit more complicated. All right, now I want you to notice that here I'm grouping the first two. See in these three terms right here, these three factors, I'm grouping the first two. Over here, those three things, I'm grouping the last two. But it doesn't seem to be in the same order. It's not, because that's 8x7 and that's x87. 8x7, x87. But I want you to notice something. What we did first, you see how we have 8 times x, and all of a sudden I have x and 8 listed? So basically what they did first was this right here, they did the commutative property. So they used a commutative property to go from here to here. They did that first. So basically what they did was they said, all right, well, 8 times x is going to be the same as x times 8 times 7. All right, so to go from here to here, they used the commutative property of multiplication. Okay? Now, to go from here to here, what they then did was, now see how this order is now the same as this, x87? So instead of grouping the first two, we'll do this. They grouped the last two, and that's what this is. So the answer to this whole thing, and remember to go from here to here, that's to go from here to here, that's the associative property of multiplication. And so the answer to the whole thing, to go from here to here, was they used two things. They used commutative property, and then they also used the associative property. So in the blank, you would say commutative property, commutative and associative properties of multiplication. All right. So number 8 was a little complicated because it's hard to see those two things sometimes. We're using two different properties. Okay, so that's going to take care of this lesson.